Hello, it's Ian here from Crack Maths and welcome to this tutorial, question and answer video on compound measure, where we're specifically going to be looking at the compound measure formulas for pressure and for density. Okay, so let's get started with question one. Question one says, a force of 30 newtons is applied to an area of 6 meters squared. Calculate the pressure. And it says here, answer in newtons meters squared, newtons per meter squared. So this is the big clue here, and that tells us what pressure is equal to. So if pressure is measured in newtons per square meters, what we know is that pressure is equal to newtons divided by meters squared. Or if you remember the formula will be force over area. Okay, so that's what we're looking at for pressure. We're looking at pressure is the force divided by the area, but specifically it has to be these units, newtons and meters squared. So if you get given information in other units, you need to make sure that you change it into these units first. So we can now look at what we've been given in the question. So a force of 30 newtons is applied to an area of 6 meters squared. Calculate the pressure. So as we said, the pressure equals the newtons over meters squared, which is the force over the area. So we can put these numbers in and then we'll be able to get our answer. So the force is 30 newtons and the area is 6 meters squared. So it's 30 over 6. And so 30 divided by 6 is going to be 5. Okay, so the answer would be 5 newtons per meters squared. Okay, like this. There we go. So that would be our answer for question 1. Okay, right, let's have a look at question 2. So question 2 here says the pressure on a surface is 50 newtons per meter squared and the force is 200 newtons. Calculate the area. Answer in meters squared. So this time we've got different information, but it's all the same. So we can still use the units here, newtons per meter squared, to remind ourselves that pressure equals newtons over meters squared. Okay, and then we can put in the information here. So if we know that the pressure here is 50, we get 50 is equal to the force, which is the newtons, 200 newtons, 200 over the meters squared, which is the area. So I'm just going to call that A. So 50 equals 200 divided by A. Okay, so what we now need to do is we need to rearrange this formula so that we can work out what A is. Now, if you don't know how these rearrange, what I'm going to quickly do is I'm just going to quickly use my pen and to think about this calculation with different numbers, okay? So let's say we've got, I know that 2 equals 6 divided by 3. Okay, so let me move that out of the way there. So if I know that 6 equals 2 divided by 3, I can think of this as in the position of the 2, this in the position of the 6, and this in position of the 3. Okay, and now what I know is I also know that 3 equals 6 divided by 2. Okay, so and what you can notice here is basically that's just a switch of these two things. So I've just switched these two. So what I'm going to do now is I'm going to rewrite this question here. So if we think about it that we're switching these two, this is the reverse calculation, we're going to get that the A goes here, so the A is equal to the 200 divided by the 50. Okay, now 200 divided by 50 is like 20 divided by 5. 20 divided by 5 is 4. So we would get the area for this is 4 meters squared. Okay, so there we go. That's the answer to question 2. Right, let's have a look at question 3. So question 3 here says that a woman stands on the ground with a total contact area of 0.025 meters squared under her shoes. Her weight, the force, is 600 newtons. Calculate the pressure she applies to the ground. Answer in newtons per meter squared. Okay, right, so if we want to answer this in newtons per meter squared, so remember we've got the pressure equals the newtons divided by the meters squared. So that's going to give us, the pressure is what we don't know. So we don't know the pressure. We do know that the force is 600. And then we do know that this is 0.025. So now what we can do is we can just calculate that. Okay, so let's get the calculator out for this one because this is a little bit harder. So we've got 600 divided by 0.025. There we go. And so what we're going to get there is that's 24,000. And I can just move this out of the way and write down the units. The units for this would be newtons per metre squared, because we've done newtons divided by metres squared. Okay, right, let's have a look at question 4. And question 4 says, a force of 900 newtons is spread over an area of 3 metres squared. Calculate the pressure, answer in newtons per metre squared. Again, this is a nice one. It's the pressure is equal to newtons over metres squared. Okay, the force here is in newtons and the area is in metres. So this is very pleasant. So we're going to do 900 divided by 3. Okay, so 900 divided by 3, well, that is 300. And remember, the units is newtons per metre squared. But they'll always usually give you these at the end of the question in your exam anyway. Okay, so let's have a look at question 5. So question 5 here says, a pressure of 12 newtons per metre squared acts on an area of 8 metres squared. Calculate the force, answer in newtons. Okay, so this time, remember, we've still got the same formula from above because we know it's newtons per metre squared. So pressure equals newtons over metres squared. But this time we've got the pressure. So we've got the pressure is 12. So 12 equals, we don't have the newtons, we do have the meters squared. Okay, so 12 equals n divided by 8. Okay, I'm actually just going to write this the other way around because it makes it kind of easier for us to think about. So I'm going to say that n divided by 8 equals 12. Okay, well, if I've got n divided by 8, I actually just want n. So I just want the force by itself. So if something's been divided by 8, to undo that, we've got to times that by 8 here. And this is a direct proportional setup here. When one thing equals another, these both have the same value. So if I'm multiplying the value of this side by 8, I've got to multiply the value of this side by 8 as well. And that's going to give me, well, 12 times 8 is 96. So here we go. The force of this would be 96 newtons. Okay, great. Okay, right, let's have a look here at practice question number 6. So this time we're now moving on to mass and density. Okay, so here we go. It says a material has a mass of 240 grams and a volume of 80 centimeters cubed. Calculate its density in grams per centimeters cubed. So what this means this time is it means that the density, I'll call it D, is equal to the grams over the centimeters cubed. Okay, and the mathematical name for grams in this case is the mass. So grams tells us the mass, and the volume, well, the centimeters cubed tells us the volume. Okay, but these units are important. Okay, if you want to do a density calculation, you generally have to have grams and centimeters cubed. That is kind of like the standard units that they use, unless they specify something a bit different, maybe like kilograms per meter cubed, but that's a little bit rarer. So now we've got this. So we've got the density equals the grams over the centimeters cubed. So let's have a look here. We want to know what the density is. And this time we've got the grams, it's 240 grams, and it's 80 centimeters cubed. So we just need to do 240 divided by 80. I can get rid of the zeros there because that's like dividing both the top and bottom by 10. So we're looking at 24 divided by 8. 24 divided by 8 is 3. Okay, and remember the unit is grams per centimetre cubed, so it's 3 grams per centimetre cubed. Right, question 7. So question 7 says, a material has a mass of 240 grams and a volume of 80 centimetres cubed. Calculate the density. Again, oh, that's like the same. Is that the same question? It is the same question. Okay, I'm going to roll with it here, but I will change this. Right, so if the mass has a volume, if the mass has 240 grams and the volume is 80, let's work this out again. So we know that the density equals the mass over the volume. Okay, so the mass is 240, the volume is 80, and then again this is 3 grams per centimetres cubed. Okay, sorry about that error. Right, question 8. Question 8 we have here is a liquid has a density of 1.2 grams per centimetres cubed and a mass of 480. Calculate the volume of liquid. So remember, it's grams per centimetres cubed, so the density equals the grams over the centimetres cubed. Okay, so in this case, we've got the density this time. So we have 1.2 is equal to the mass, which is the grams, so the 480, over the centimetres cubed, which is the volume. So here we go, we've got 1.2 equals 480 divided by V. Now, remember from what we were discussing earlier, if we've got this set up, we can actually just switch these two things round. Okay, so what I can get here is I can get the volume is equal to the 480 divided by the 1.2. Okay, and so this is a job for the calculator. So let me bring this on here. So we've got 480 divided by 1.2. Here we go. And that gives us an answer of 400. And that will be in centimetres cubed. Okay, there we go. Right, let's have a look at question 9. Okay, so question 9 says, a block has a density of 7.5 grams per centimetre cubed and a mass of 600 grams. Find the volume. Okay, so we've got the density equals the mass over the volume. Okay, remember, I'm only remembering this because of this unit thing, because of the grams per centimetre cubed. So density is the grams over the volume. Okay, so what we have here is 7.5 is equal to 600 divided by the volume. And remember, we can switch these two here because of our reverse calculation. So we get the volume equals 600 divided by 7.5. Okay, and let's do that again on the calculator. So here we go. 600 divided by 7.5, and that equals 80. And that is centimetres cubed. Okay, I kind of ran out of space there. Sorry about that. Okay, so let's move that there. Let's have a look at question 10. Okay, so question 10 says, oh, we've got different units. Container holds 2.5 litres of oil with a density of 0.9 grams per centimetres cubed. Convert the volume into centimetres cubed and calculate the mass. Okay, volume is centimetres cubed, mass in G. Okay, right, so, well, first of all, what we can do is, I know that, I'm just going to make a note of here, down here, 1 milliliter equals 1 centimetre cubed. Okay, that's an important thing that we actually do need to know. 1 milliliter is 1 centimetre cubed. And we also need to know that 1 litre equals 1,000 millilitres. Okay, so 2.5 litres equals 2.5, this times 2.5, which is this times 2.5, which is 2,500 millilitres, which is equal to 2,500 centimetres cubed. Okay, right. So there we go, we've got the volume now. The density we've been given, it's in grams per centimetres cubed, which is good because we've now got our volume in centimetres cubed. So let's have a look here. We've got 0.9 is our density. I'm going to just reuse this formula from up here. Is mass over volume. So it's the mass divided by the volume, which is 2,500. Okay, now I'm going to rewrite this way round. So we've got mass over 2,500 equals 0.9. Okay, now remember what we've got here is we've got something divided by 2,500 equals 0.9. So we don't want this to be divided by 2,500 anymore. So we need to times both sides here by 2,500. Now remember, we can do that because the equal sign tells us that this quantity is the same as this quantity. So if we multiply this quantity by 2,500, we'll get the same value as if we multiply this quantity by 2,500 because they're both the same. Okay, so m divided by 2,500 times by 2,500 just leaves us with m. So I get m here is equal to this. And then 0.9 multiplied by 2,500, well, I've got to bring this over here and do it like this. So we've got 0.9 multiplied by 2,500, and that equals 2,250. Okay, so I'll just write that here. So that's going to be in grams because that's the mass. So the answer to that is 2,250 grams. Okay, so we've got the volume in centimetres cubed down there, and we've got the mass over here. That was a little bit tight fitting those all in there, but never mind. Let's move on to the next one. Okay, so we've got the scenario questions now. Okay, so let's have a look at these scenario questions here. So a pressure cooker lid has an inside surface area of 0.05 meters squared. The pressure inside reaches 9,000 newtons per meter squared. Calculate the force on the lid. Okay, right. So again, remember, so we've got the pressure is equal to the newtons over the meters squared. Okay, and we're told that the pressure is 90,000. And so this equals, we've got the surface area. Okay, that's the meters squared. So we need the force. So we're calculating the newtons. And so we're going to say that the area is the 0.05. Okay, right. So let's have a think about this one here. So I'm going to rewrite this the other way around. So we've got n divided by 0.05 equals 90,000. Now, remember, both of these quantities are the same. And what we want is, we want this n to no longer be being divided by 0.05. So what we have to do is we have to multiply by 0.05 because n divided by 0.05 multiplied by 0.05 takes us back to the newtons. It takes us back to n. So I'm just going to put here times 0.05. Now remember, because the values here are the same, even though they're written differently, we multiply this side by 0.05 as well, and this is going to give us the answer. So here we go, n divided by 0.05, then times by 0.05 takes us back to n, and then 90,000 times by, that's just 90. 90,000 times by 0.05 is equal to 4,500. And that is newtons, okay? So we've got 4,500 newtons as our answer. Okay, so question 2 says, a student pushes down on a block with a force of 45 newtons. The block's base area is 0.15 meters squared. Calculate the pressure on the bench, answer in newtons per meter squared. Okay, so we want the pressure, it's equal to the newtons over the meters squared. Okay, so the newtons are 45, so the P equals the 45 divided by the 0.15, okay? Oh yeah, that's fine. Newtons per meter squared. Okay, great. So 45 divided by 0.15, let's get out the calculator for that. 45 divided by 0. That's 1, 0.15. And that equals 300. There we go. Right, so let me remove that. And that will be 300 newtons per meters squared. Right, question 3, let's have a look here. So we've got a person weighs 700 newtons. Wearing heels, contact area is 0.0015 meters squared. Wearing trainers, their contact area is 0.025 meters squared. Calculate the pressure for each. Okay, fine. So let's do this one first. So we've got the pressure is equal to the weight, the newtons, divided by the meters squared. So in this case, it's going to be, for the first one, it's going to be 0.0015. That's going to be for person one, for the situation 1, and I'll write out the thing for the situation 2 here, and then I'll get out the calculator and we could do it all together. So we've got here the second one, we've got the pressure is equal to 700 divided by 0.025. Okay, now let's get the calculator out to work out both of these, and then we can see what the difference is. Okay, so 700 divided by 0.0015. Whew, that's a lot. 466 bracket 666, and I'm going to say 0.7 there, so I'll round that up there. Okay, so 466,666.7 newtons meters squared. And then let's have a look at this other one. So we've got 700 divided by 0.025. And there we go. That's 28,000. And that's newtons per meter squared as well. Right. Wow. So there's a big difference on the pressure on the ground from somebody wearing heels to somebody wearing trainers, which makes sense probably because if someone steps on you in heels, it's a lot more painful than if someone steps on you in trainers. Okay, right. Let's have a look at question 4. Okay, so question 4 says, a driver experiences a pressure of 40,000 newtons per meter squared underwater. A diver. Okay, the area of their wetsuit under pressure is 1.8 meters squared. Calculate the force acting on them. Okay, so we know the pressure this time. So we've got the pressure is 40,000. We don't know the force, that's what we're after. I'm going to call it F this time for force. It's actually usually called, if you got this as a formula, they'd call it force. And then we've got the area, force over area is going to be 1.8. Okay, so again, I'm going to rewrite it like this. F divided by 1.8 equals 40,000. Okay, now I want F to no longer be divided by 8. So what I'm going to do is I'm going to times both sides by 1.8. Because remember, F divided by 1.8, then multiplied by 1.8 takes us back to F. And then because these values are the same, this is a direct proportional thing. So I have to do the same to this side as well. So if I multiply this side by 1.8, we will find the value of F. So let me do this here. So we've got 40,000 multiplied by 1.8. And there we go, 72,000 newtons. Okay, right, there we go. Let's have a look at question 5. Okay, question 5 says, a car exerts a total force of 12,000 newtons on its 4 tyres. The total contact area with the road is 0.04 meters squared. Calculate the pressure on the road. Okay, so remember the pressure is equal to the newtons over the meters squared. So we've got the pressure equals the 12,000 newtons divided by the meters squared, which is a 0.04. Okay, so here we go. We're going to have 12,000 divided by 0.04. 12,000 divided by 0.04. And that equals 300,000. Okay, so remember the units, well, they've given us the units there, and they'll probably give you the units in the exam as well. So we've got units is newtons per meter squared. So here we go. Right, last round of questions. Okay, so what we've got here is we've got a stone has a mass of 1.5 kilograms and a volume of 600 centimeters cubed. Convert the mass into grams and calculate the density. It's nice that there's done this because it's reminding us, but I don't know if we'll always be reminded. So you just have to make sure that these things do tie together. So let's have a look at this. And so the stone has the mass of here. So we need to turn this into grams first. So again, 1 kg equals 1,000 grams. So 1.5 kg is 1,500, okay? So I'm going to just write that down here. So we've got the mass equals 1,500 grams. Now, the density is grams per centimetres cubed. So we know that D is equal to the grams over the cm cubed. Okay, and in this case, the grams is 1,500 and the centimetres cubed is 600. Okay, so we're just looking at doing 1,500 divided by 600. Let's see if this gives us something nice. There we go, and that's 2.5. So that's our density. 2.5 grams per centimetres cubed. Okay, right. Let's have a look at question 7. Question 7 says, a scuba tank holds 8,000 centimetres cubed of air. Density of air equals 0.0013 grams per centimetres cubed. Calculate the mass of the air in the tank. Okay, calculate the mass of the air in the tank. So we've got the density is 0.0013, and that's grams over centimetres cubed. So that's the grams divided by the centimetres cubed, which is 8,000. Now remember, with this situation, we can just switch these two. Okay, and so, that's not going to help us actually. So we could switch these two, but because neither of those are the unknown one, it's not going to help us actually. So I will get rid of that. And then what we're going to do is, remember, we've got the grams divided by 8,000 equals 0.0013. So I want the grams to no longer be divided by 8,000. So what I've got to do is I've got to times them by 8,000, and then times this side by 8,000 as well. So we get the grams is equal to 0.013 times by 8,000. So here we go, we've got 0.0013 multiplied by 8,000. And there we go, so that is 10.4 grams. Is that it? No, so the grams equals 10.4 grams. Yeah. There we go. Calculate the mass of the air in the tank. So the mass of the air in the tank is 10.4 grams. And that makes sense because you wouldn't imagine air to be very heavy. If you try lifting air, I don't know how you lift air. But yeah, it wouldn't have much weight to it. And 10.4 grams isn't a lot. Okay, so let's have a look at question 8. Question 8 says, a piece of wood has a density of 0.6 grams per centimetres cubed and the volume of 3,000 centimetres cubed. Calculate the mass. Okay, right, so we know that the density is 0.6. Okay, it's grams per centimetres cubed, so the grams goes on top. We know the volume. Okay, so the volume is the 3,000. So we're calculating the mass, we're calculating the grams. Okay, so again, grams over 3,000, we have to multiply that by 3,000, so it becomes just the grams. Okay, or the mass. In fact, let's change this to an M here because they're talking about mass and that'll be clear. So mass and grams are the same thing. The grams is the mass. Okay, so and then this was equal to 0.6. So 0.6 times by 3,000. It's going to be something to do with 18. So 0.6 multiplied by 3,000. Yeah, 1,800. Okay, so here we go. We've got the mass is 1,800 grams. State whether it will float in the water. Oh, this is an interesting extra bit to the question. So it says state whether it will float in the water Water density is 1 gram per centimetre cubed. Well, this is 0.6 grams per centimetre cubed, so it will float because it's lighter. Okay, 1 gram is heavier, so that's generally how things float or sink. If they've got a higher density, they sink to the bottom. If they've got a lower density, they rise to the air. Like if we look at the density of air, it was 0.0013, so that's why air's floating everywhere. Okay, right. Anyway, let's. That's my attempt at teaching science. Right, let's have a look at question 9. So 9 says a gold bar has a mass of 3.6 kilograms. The density of gold is 19.3 grams per centimeters cubed. Calculate the volume. Answer in centimeters cubed. Okay, so we've got a bit of a trick here. 3.6 kilograms, we need to turn that into grams. So we times that by 1,000, so that's 3,600 grams. So remember the density, it's the units are given here. Remember the key is always in the units, is grams over centimetre cubed. So we've got the grams, we've got the density. So we know that 1.9, we know that 19.3 equals 3,600 divided by the centimetres cubed. Okay, now remember we can actually just switch these two round to find out what the centimetres cubed is. So the centimetres cubed, or we should say the volume, is equal to, if I switch those two things around, so it's 3,600 there and the 19.3 here. So the centimetres cubed is equal to, let's write this down here, 3,600 divide 19.3. Here we go, 186.5. I'm going to say that's to 1 decimal place. Let's just move this over here and then I can fit the rest of it in. So actually, I'll put that there. But I'm going to say the volume equals 186.5 centimeters cubed, and then that's to 1 dp. Okay, right, there we go. Right, and therefore the last question that we have is question 10. Okay, and question 10 says a fish tank measures 50 by 30 by 20 centimeters and it's full of water. Density is 1 gram per centimeters cubed. Calculate the mass of the water in kilograms. Hey, okay, right. So first of all, this is going on our knowledge of volume. So first of all, we've got to work out the volume of this. So the volume of a cuboid is length times width times height. So we've got to do 50. Well, they've put the times in there for us, 30 times 20. I'll do the 50 times, well, I'm actually just going to do it on the calculator. We could do this manually. 50 times 30 times 20. Here we go, so that's 30,000 centimetres cubed. So that's the volume. Right, and then the density is equal to 1. So we know that 1 gram, or like 1, the density is 1. The mass we don't know, but the volume is 30,000. Okay, so again, let's write it like this. So we've got mass over 30,000 equals 1. So in order to get the mass by itself, we've got to times it by the 30,000, because mass divided by 30,000 times 30,000 takes us back to the mass. Okay, that's too many zeros. So we've got the mass here, and I times this by the 30,000 as well. Well, 1 times 30,000 just gives us 30,000. So the mass is 30,000 grams. Now, every 1,000 grams is a kilogram. So if we listen to it, it's 30,000, which means it's 30 lots of 1,000. So therefore, it's 30 kg. Okay, great. Right, well, thank you very much for that. And I will hopefully see you in another video. Cheers, bye.